Diagonal-Achoo. In a network of top-secret underground research facilities, a group of rogue scientists are conducting unethical experiments using a synthetic, fast-mutating pathogen known as Diagonal-Achoo. This virus spreads exclusively along diagonal paths, infecting ordinary test subjects unless blocked by specially engineered immune individuals, the H-class prototypes. You're given G-square grids representing G different simulation chambers. Each grid is of fixed size, n times n, and each cell may contain dot, which is a normal unaffected person, H, a healthy person, immune, C, a contagious person. The infection unfolds turn by turn, independently in each grid. During each turn, every contagious person, C, sneezes and infects diagonally adjacent normal persons. But the sneeze pathway is blocked if it reaches a healthy person. Infected persons dot turn to C become contagious in the next turn and continue spreading. Your task is to simulate the spread of infection in all grids until the infection stops, i.e., no more new infections. Print the index zero based along with the aftermath of the grid that ends up with the most infected people, including both initially contagious and newly infected. If a tie occurs, choose the grid with the lower index. Example of spread infections, which is this. Input first line integer n size of the grid n times n. Second line integer g number of grids. Next g times n lines. For each grid n lines follow, each a string of length n representing rows of that grid. Output first line index of the grid with the most infected. Next n lines, the grid with the most affected. Constraints. Once 1 less than equal to n is less than equal to 10. 2 is less than equal to g, which is less than equal to 50. So that's the example of the input and the output. These are the test cases, and to solve this problem, I'm going to use Python. Let's do it. Right, okay. So, after showing you the code for this puzzle, I'm going to explain how I did it. So, this program simulates how an infection. Let me repeat that, sorry. This code simulates how an infection spreads diagonally across several square grids, then works out each grid ends up with the most infected people. It begins by reading in the size of each grid and how many grids there are. Each grid contains three types of people: C for contagious, H for healthy, who can't be infected, and dot for normal, unaffected people. In the simulate infection function, which is here, the code repeatedly spreads the infection from every contagious person to any diagonally adjacent normal person. It keeps doing it until no new infections occur. A copy of the grid is used during each round so that changes from one step don't affect others midway through the turn. Once the infection has fully spread, the counted infected function, which is here, simply counts how many C's are in the grid. In the main part of the code, which is right here, it goes through all the grids, runs the infection simulation on each, and records how many people became infected. It then compares the results to find which grid ended up with the most contagious people. If two grids have the same total, it chooses the one that appeared first. Finally, which is here, the code prints out the number of the most infected grid, followed by what the grid looks like once the infection has finished spreading. And I will show you that one more time. And that's it. And that's how I solved this puzzle.